Hello everyone. So this video is the beginning of a new series where I will share solution to the questions which I will call question of the week. It is like transformation of the already ongoing series in my Instagram where I share some questions which I call weekday challenge every Monday and their solutions on Saturday or Sunday. So this is like that. The questions are on different levels. This particular one is up to JEE advanced level. So JEE students can definitely watch it. One more thing, the solution will be in English so that more people can understand it and watch it. So you can try it on your own and we will try to solve this. So at first the question may look terrifying, like there are many elements, many different concepts may be used, but we can divide and conquer. We can first look at this part and somehow evaluate this. So if we know the basic and have practiced definite integration, then this is not that hard to solve. Let's call this expression I. Then if we apply King's rule, we can also try to apply like check if this function is odd or even, but you can quickly check this is neither odd nor even. So let's apply King's rule. So we know King's rule, we can rewrite x as a plus b minus x. Here a plus b is 0. So 0 minus x. So e2. And we know mod here, mod, it is written mod. So mod of minus x is just x. So this is just mod x. Since minus of mod x is equal to mod x. I will not be writing such explanation further in the video. You can understand it yourself if you are paying attention, or you can do the work, which I am skipping. So this will be minus sine x because sine of minus x is minus sine x. So now what we can do, we can just add these two expressions, or let's first simplify this. We can rewrite this as 1 by e to the power sine x and take LCM. So we will get e2 fractional part of mod x. Sine x will come in, e to the power sine x will come in numerator. And here we are left with, we will be left with e to the power sine x plus 1. So we can rewrite dx also. Now we can just add these two expressions, and if you can imagine, or if you have practiced such type of question, then we can see that e to the power 2 fractional part of mod x is common, and we are left with e to the power sine x here and 1 here. So you can see that numerator and denominator become same. It will get cancelled out, so I'm not writing that. So it will become this, and obviously the limit is minus r to r. Here also we can write this. So now you can observe or apply another concept. So first we have applied King's rule. Now this function has become, you can see odd even function. So this is even function because mod is even. So it will not change. So we can rewrite this as from 0 to r 2 times e to the power 2. We can rewrite mod x, but we know it is positive. Since r is a positive number, r goes from 1 to n. So it should be a positive number. So we can eliminate mod x is equal to x in the positive region. So we can rewrite this, okay, by even property, even function. So this 2 and 2 will get cancelled out. Now we have to somehow this fractional, eliminate fractional part. If you notice that fractional part is actually a periodic function, like its graph is like this. And if you want to evaluate from like 1 to n, 1 to some integer, 0 to n, f of fractional part dx is same as n 0 to 1. This is a famous periodic property. It should be fx dx, n times fx dx, because fractional part is periodic with period 1. F of fractional part is also periodic with this. This would make sense because if we somehow want to evaluate like this, so these are all the areas are same. Definite integration is nothing but the area. So all these are same. So instead of calculating from 0 to 4, we can write 4 times integration 0 to 1. So I'm writing this only. So I becomes 2 times into r. R is an integer. This is not given, but we can make sense because there is sigma. So r goes from 1 to n. So it will be like r is equal to 1, r is equal to 2, r is equal to 3. So r should be an integer. Otherwise the sigma will not make sense. And we know in between 0 to 1, the fractional part is x itself. So we can rewrite x itself. So now we can see the 2 is cancelled out. Why I've written 2. So now this is simple integration. So somehow this complicated expression with some basic concepts of definite integration becomes a simple integral to evaluate. So this is e to the power 2x by 2. Integration of ex is itself. For 2 we have to divide it by 2 from 0 to 1. So this becomes r e square, e to the power 0 is 1 by 2. So our integral part is done and calculated. So here we can see there is a constant, e square minus by 2 is a constant and r is a variable. So we'll keep the r and evaluate the rest. So let's evaluate here. So we can take out what we are doing. Now we are calculating the sigma and we can take out the e square minus 1, and there is also e minus 1, so that will be cancelled out. We can also take e minus 1 because it is a constant, and obviously there was a 2 in the denominator. So I'm calculating sigma, or let's write limit also. We are left with limit n to the power infinity sigma r is equal to 1 n. There was a r plus 1. So somehow we now have to evaluate this expression. So this is also a famous expression with a little bit of manipulation, plus 1 minus 1, and we can just separate these two expressions, like first r plus 1, then minus 1, then r plus 1 by r plus 1 factorial. It is simple, you can calculate in your head. It will become r factorial, and 1 by r plus 1 factorial will remain itself. We have sigma r is equal to 1 to n, and now this becomes telescopic series. You can evaluate on your own by rewriting, and terms will get cancelled out. Only the first term r is equal to 1 will be left, and the last term 1 by n plus 1 will be left. You can calculate it yourself. You can do this thing so that you can understand it better, or if you already understood it, that's great. So sigma is evaluated, we are left with first term and last term, and this is e minus 1 by e square minus 1 will become, or rewrite here, this is e minus 1 e plus 1, so e minus will get cancelled out, e plus 1 by 2, so we are left with e plus 1 by 2. Now what we can do, this is limit n tends to infinity, we can see. Lastly, we have to evaluate the limit. So as n tends to infinity, n plus 1 factorial will tends to 0. So we are left with only 1. So the answer is simply e plus 1 by 2. That's it. That's the solution, and that's the answer. I hope you liked the question. It is created on my own with some inspiration. And yeah, this is the solution. That's it. And I hope you liked the question and the solution. More importantly, the explanation part. And I hope you will be excited to see the next question of the series. If you have any other solution, you can comment. Okay, that's it for today. I hope you learned something new. See you in another video. Thanks for watching.